In this session, we're going to go over the quiz 3 problems. Okay, here's the first one, the exponential model, A equals 10.2 e to the 0.021 t describes the population A of a country in millions t years after 2003. So we're given the model, and we're given that A is the population in millions, and T is years after 2003. Use the model to determine the population in the country in 2003. So if T is years after 2003, and it's 2003, then T is 2003 minus 2003. So T is going to be 0. So we're going to substitute 0 into this function that we're given, 10.2 e 0.021 to 0 power. And e, or 0.021 times 0, which is 0. So we have 10.2 e to the 0. Anything to the 0 power is 1. So we have 10.2 times 1, which is 10.2. So this is going to be 10.2 million people. I'll just type in 10.2 into this for the answer. Okay, the next question, complete the table shown to the right for the population growth for a certain country. The projected 2041 population is, we need to get that in millions. And so let's use the exponential growth model. The exponential growth model is A of T equals the original population, A initial, E to the growth rate, K, T. Okay, so it looks like we're given the population in 2007, 84.7. We need to know the projected population in 2041. And then we're also given K, the projected growth rate. Okay, so for this one, this is going to be your initial. And this is going to be your final, the A of, so this value, and then the K is given. And let's find the projected population in 2041. Okay, so A initial is 84.7. We have E, then K is given as 0.0059. T, it looks like T we're not given, but if you think about what T is going to be years after 2007. And so I'm going to do that here. T is going to be 2041. We're going to take away 2007. And so that's 2041 minus 2007. It's going to be 34. And so let's use 34 as our T value. And that's going to give us the final value, the projected population in 2041. We're using 34 because that's 34 years after 2007. Okay, so that we can plug into the calculator as 84.7 times E 0.0059 times 34. And we get 103.5. It says 1 decimal place, so I'm rounding it to the 0.5. So we'll type that in. And then we're done with that problem. So we can move on to number 3. Here it looks similar. We're given population growth model. This time we're given the initial population, 2006. The projected population is 2039. We don't know the projected growth rate, so we need to find that. Okay, so I'm going to write the model again. So A of t was the initial, A naught, E to the KT. And let's find T. Okay, because we can find that T is, I'll do it right here. T is 2039 minus the starting year, 2006. And so that's going to be 33. So we know T, we don't know K, we know the initial, and we also know the projected population. And then, so we have everything we need to find the K value. Okay, so the projected population is 53.2. The initial is 58.8. E, K, we don't know. Then we have 33. So instead of putting 33 after K, we'll put it in front of K. Okay, the first thing we need to do to solve for K is divide both sides by 58.8. Okay, so we have 53.2 over 58.8 equal to E 33K. And then to cancel the E, we have to take the ln of both sides. So ln of E is going to cancel out. And then we have ln of 53.2 over 58.8 equals 33K. So one more thing we need to do to cancel that 33 is divide both sides. And so we have isolated for K, and let's put that in the calculator, and that'll give us our K value. So we do ln of, I'm going to use my fraction, 53.2 over 58.8, close my parentheses, and then divide that by 33. And it says to round to 4 decimal places, so it's negative 0.0030. Oops, 30. It's negative because the projected population in 2039 has fallen from 2006. Okay, let's go to the next one. Okay, we have the half-life of a certain tranquilizer in the bloodstream is 39 hours. How long will it take for the drug to decay to 90% of the original dosage? And we're going to use the exponential decay model to solve. And so we're going to be looking for the number of hours. So let's see what we have. It's always good to start with what we have and then work our way to find out what we need to get. Okay, so it says the half-life of this tranquilizer is 39 hours. And then it says how long, so we need to find T, how long will it take for the drug to decay to 90%. So the final value saying that's decreasing to 90% or 0.9 of the original dosage. Okay, so we're given A. We're not really given initial, but if you think about what initial value is, it's always 100%, right? Because you always start with 100% of the original value. I'm going to change that to decimal form, which is 1. We don't know K, we don't know the growth rate, and we're not really given, we're trying to find T because it says, right, the number of hours. And so first we need to find K. So first find K using the given half-life and the other values. So for A, right, we're given that the half-life, so the final amount half-life of the initial value. So whatever the initial value is, 1, E, K, and then 39. I'm going to put 39 first. So you need to use the half-life model to find the K value, the growth, the decay rate. Let me get my eraser, my K. So first we have to find K. And so to find K, we can ignore this one. We're going to do ln of both sides. E 39K. ln of E is just 1, so we have ln of half is equal to 39K. Divide both sides by 39. We're going to get that K is equal to ln of half over 39. So let's find out what the K value is first of this tranquilizer. And then we're going to go back and then find the number of hours it took to reduce to 90% of its original dose. And so let's put ln 1 over 2 parentheses divided by 39 is, I'm going to write that down. So this is not the answer. This is the K value that we're going to use to find our answer, 0.01. I'll do 7, 8 to round to 4 decimal places. Okay, so we're going to use that value. And so let's go back. Okay, so I need to rewrite the model. So now we're going to find, so part 1, we're going to find the T. So rewriting the model again, A equals initial A value EKT. Okay, we know that we want to go to 90% from the original dosage, which is 1, because it's 100%. E. K we found was negative 0.0178. T is what we're trying to look for when the original dosage, 100%, goes to 0.9. To repeat the process, we're going to do ln of both sides because we can ignore that 1 again, right? 1E is just E. And so if we do ln of both sides, ln of E, negative 0.0178 T. And then ln of E cancels. And so we have ln of 0.9 equals negative 0.0178 T. Divides both sides. That's by negative 0.0178. Negative 0.0178. And I'll put that in the calculator. So ln of 0.9 divided by negative 0.0178. And that's 5.9, round to 1 decimal place. So after 5.9 hours, it's going to reduce the original dosage, 100% reduces down to 90%. Let me put that in here. So rounding to 1 decimal place is 5.9. Okay, let's look at another half-life problem. So it says complete the table shown in the right for half-life of a certain radioactive substance. So that's going to be the T value that it'll take for this to reduce to half of its original amount. So write down the half-life model. A equals the A initial E K T. And so we start with initial is 1, half-life, the final amount is half. It doesn't matter what the exact amount is, right? As long as we know it's half of whatever the original amount is. E, K is negative 0.068. We're trying to find the T value or the time it takes for this amount to reduce by half. So again, we don't need the 1 there anymore. So we take the ln of both sides to solve for t. So ln of v is 1, so we have ln of 1/2 was negative 0.068 t. Divide both sides by negative 0.068. Negative 0.068 cancel. And so that's going to be our t. ln of 1/2 or ln of 0.5 divided by negative 0.068. It's 10.2, so it says round to 1 decimal place as needed. So for this radioactive substance, it takes 10.2 years for the original amount, we're calling it 1 or 100%, to decrease to half of its amount. Nice. Okay, I think this is one of the longer problems. So over a period of time, a hot object cools to a temperature surrounding air. This is described by Newton's law of cooling. We have T equals C plus the initial T minus the C, E negative KT. Where T, we have lots of variables here, so we need to be careful that we use the right variables. So T is a time. Let me label it because it takes there's a lot of variables. T is time it takes for an object to cool from the initial temperature, so T not is initial temp, to the final temperature, T, and C is the surrounding temperature. Air temperature, and K is the positive constant with the cooling object. A cake, so we're given a cake is removed from the oven of 198 degrees and is left to cool, that has a temperature of 66. So this is the original temperature of the cake. So that's going to be our initial T. It is left to cool room, it's a temperature of 66. That's the surrounding temperature. It's a pretty cool room. And after 30 minutes, let's see, the temperature of the cake. So after 30 minutes, the temperature of the cake is 132 degrees. Okay, so that's part one. And we need to find what's the temperature of the cake. So what is the temperature of the cake? So this is part 2. Here we're given part 1. After, what is the temperature of the cake? After 45 minutes. So what's the temperature of the cake? The final temperature after T is 45 minutes. Okay, so let's find the, first we need to find the K, right? We don't know what K is. We're not given that. So we need to find K first in order for us to do part 2. Okay, so let's go ahead and do that. Okay, so given the model, we have T is equal to the C, which is 66, plus the initial temperature, which is 198, minus the 66. Forgot that we're given the final temperature. It's 132. And then we have E, negative K. We don't know K, but we know the time is 30. So let me put negative 30 K. Okay, so let's simplify as we go. 132 equals 66, and 198 minus 66 is going to be 132. E plus sign, E negative 30K. To find K, we need to subtract both sides by 66. And so that's going to be 66 again equals 132 E negative 30K. Okay, remember here, we're trying to find the K. And to do that, we need to divide both sides by 132. I'm running out of space here. And now we have 66 over 132. Was E negative 30K. Okay, to cancel the E and we're really using the power rule to make this come down, right? We have ln of both sides. Ln of E is going to cancel. And so we got ln of 66 over 132 is equal to negative 30K. To find K, we're going to divide both sides by negative 30. So we have our K now. We have ln of 66 over 132 and divided by negative 30. So our K value, I'm going to write that here. Our K value that we found is negative or positive 0.0231. So I'm going to write that here, 0.0231. Okay, now we have to do part 2, right? We haven't done part 2, so we actually need to find K to do this problem. Now I'm going to do it up here. So now we have to find the final T. Okay, and given everything else is the same, except we're going to find what is T when the surrounding temperature is still the same, so 66, plus the initial is still the same, we have 198 degrees of the cake, minus the surrounding temperature, C, E. Now we have K, right? K is negative 0.0231, and T is 45. So we have to use 45 now, 45 minutes. So now we just have to plug it into the calculator. So 66, I have to move this over. So 66 plus 198 minus 66, E negative 0.0231 times 45. And so the final temperature of the cake, it's 78. So it's round to near this whole number. So just 78 degrees. Okay, let's try the next one, 7. Okay, here we're moving on to section 9.1, solving the system using matrices. It says use Gaussian elimination method, but I really want you to use the calculator the way I showed you how to do it in Edpuzzle. And so this matrix, right, we're going to put it in. Let's erase everything. Oops. Okay, so the way I showed you how to do it using the calculator was you need to use the matrix function in your calculator. So let's go to second matrix. We need to enter this matrix in. So we're going to go to edit and we're going to choose matrix A. And this is a 3x4 matrix because it has 3 equations. You can think of it as 4 columns. And so 3 by 4. And then it gives us a space of the first column are the X values, and the second column are the Y and the Z, and then you have the constants at the end. So the first equation is 1, 5, 0, 0. And the second one is 1, 6, 1, 1, and then 3, -1, -1, 74. This point, just want to make sure that you've entered your matrix incorrectly. I'm glancing at it, it looks good. So you're going to quit out, and then we go to second math. Oops, not second math, just math. And then actually, we go to math in second matrix. So let me do it again. You go to second matrix and go to this math, not this math. You have to go to matrix and find the math and under the matrix button. And then we're going to do reduced row echelon form. That's the RREF. And then call back your matrix. Reset A. And then it'll give you what the X value is. So here it says X is equal to 25. Y value is equal to -5. And Z is equal to 6. Okay, so here's another one. Use Gaussian elimination, but we're going to use a calculator. Here we're given 4 equations. So this is a 4x5 matrix. So let's repeat the process here. Second matrix, we're going to go to edit. This time we have a 4x5 matrix. So let's plug it in. We have the W is 1, -5, -1, -5 again, and -22. Second one is 1, 1, -1. We have 0 for Z, and then another 0. So we have W is 3, 5, 0 for Y, 1, 6. Now last equation, 0, 4, -4, 1, and 10. Again, glance at your matrix, make sure everything looks good. 3, 5, 0, 1, 6, 0, 4, -4, 1, 10. Okay, and then we're going to repeat to go to second matrix, go to math, and then choose RREF. I'm sorry, I forgot to quit. So go here. Actually, I can just recopy this. And we have that there's one solution, the W value, right, because this is W, X, Y, Z. The W value is -2, right? -2. And then the 2. And then the Y value is 0. And then the Z value is 2. Okay. Okay, question 9. We're going to do it again. Let's go to matrix and then edit. You need to enter this 3x4 matrix in. 5, 17, 3, 11, 2, 7, 3, -4, 1, 3, -3, 6. Okay, double checking that all the entries have been entered correctly. Okay, we're going to quit out, go to second matrix, go to math, to RREF, and then call our matrix A out again. So enter A, and then we get, this time we get something different, right? Usually we have 1, 1, 1 in the row. But this time we get, so we need to write this equation. We get that 1x plus 0y minus 30z equals 0. And then the second equation is 1y plus 9z equals 0. The last one, we get something like 0 equals 1. So if you look at the last equation, if you get something like 0 is equals to 1, that is not true, right? You get 0, 0, 0, 1. And so in this case, we're going to conclude that there is no solution. The solution set is empty. And so we're going to choose the last option. Okay, now for the final problem in this the quadratic function f of x equals ax squared plus bx plus c, for which f of 1 equals -13, f of -2 equals -16, f of 2 equals -36. And what's the function? So here we're given 3 points. We're really given that 1, -13, and then -2, -16, and then 2, -36. So we're given these 3 points. I'll just draw a rough graph. 1, -13, -2, -16, and 2, -36. Just down here. So we're given a graph. I did this one wrong. -2, -16 should be down here. So we're given a graph and we're trying to find what's the function that goes through these 3 graphs. And that's the function we're trying to find. What is the function that gives, that goes through these 3 points? And so to do that, we need to come up with 3 separate equations. And so if our function is f of x equals ax squared plus bx plus c, okay, using that f of 1 equals -13, we're going to have that -13, the y value is equal to a 1 squared plus b 1 plus c. Okay, so that first equation is negative. I'm actually going to extend this and need more space. Equals 1a plus 1b plus c. The second one is -16 equals a, -2 squared plus -b, -2 plus c. So that is -16 equals 4a minus 2b plus c. And we have the final one, -36 is a, and then 2 squared plus b, 2 plus c simplifies to -36 equals 4a plus 2b plus c. So here are my 3 equations. I can make a matrix out of that. Okay, so go to second matrix, go to edit. And then we have a 3 by 4. And so this is 1, 1, 1, -1. Because remember, this equation is on the other side. So you can think of this as 1a plus 1b plus c equals -1. So actually, let me just rewrite it in case it gets confusing. So remember, this is, I wrote it on the other side. This would be -13. And this would be -16. And finally, -36. Okay, so let's put it in again. -13. Okay, and the second one will be 4, -2, 1, -16. And 4, 2, 1, -36. Okay, so just making sure we put it in correctly. 1, 1, 1, -13. 4, -2, 1, -16. 4, 2, 1, -36. Okay, put out, and then we do RREFs, just copying this and then reapplying it. It gives us that This matrix shows us that A is equal to -6, B is -5, and C is equal to 2. So we'll put that function in f of x equals -6x squared plus bx. So it's -5x plus 2. And so that's going to be the function. And the way you can check is for if we were to graph this, let's see what it looks like if we were to graph this. It's kind of hard to see with all that. -6x squared minus 5x plus 2. Let's say graph, and I'm going to zoom out. And we're actually going to zoom out again. Well, maybe I zoomed out a little too much. But so how we can check whether it goes through these values is we can actually go to the table and look at when it's 1. I must have did something incorrectly. Okay, I'm checking. It looks like we did something incorrectly because at 1, it should be -13 and -2. So I need to go back and check to see what I did incorrect here. Okay, let's check our matrix. Sometimes it might be the matrix. So we have 1, 1, -13, 4, -2, -16, 4, 2, 1, -36. -13 is equal to A, 1 squared plus B1 plus C. So this is good. 1A plus 1B plus C equals -13. And we have A is -2 squared plus B -2 plus C equals -16. So that's 4A minus 2B plus C equals -16. So that looks good too. And the last one is 2A2 squared plus B2 plus C equals -36. 4A plus 2B plus C equals -36. Okay, I'm not seeing any errors here. One, -13, 4, -2, 1, -16, 4, 2, 1, -36. Ah, okay, I made a mistake. It was, okay, it was staring at me all this time. So it's good that I checked. C is, I bet someone noticed it before. And so C is actually -2, and I have to put -2. All right, let's go back and graph it. So it's a good thing I double checked myself. So this is minus. So if we graph, okay, now we go to table, it should match. So at 1, you can see 1, -13, -2 is -16, and at 2, you're given -36. So the function that we have here does go through all those 3 points. And so I think this is a good example of how a single negative matters. Sign matters. So just make sure that you put in negatives where you need to, like don't do what I did here. But it's a good example to show that, you know, a negative makes a big difference, and negatives always get me all the time. So just be careful with those. All right, so we're done with all 10 problems. And then you can just submit the quiz. But again, quizzes you can take as many times as you like. So that it's good for practice, because I just have them have this to be unlimited attempts so that you can practice as many times as you want to get ready for the exam. Right, I hope you found that helpful. Again, if you have any questions, please let me know, and feel free to reach out. Right, I hope you have a great day and a good week.